Hello, I'm Nuri Bang. I'm going to talk about a survey on blockchain technology, evolution, architecture, and security. It's published in IEEE Access in 2021. This publication presents a comprehensive survey of blockchain technology's evolution, architecture, development frameworks, and security issues. This also presents a comparative analysis of frameworks, classification of consensus algorithm, and analysis of security risks and cryptographic primitives that have been used in the blockchain so far. Finally, this paper elaborates on key feature directions, novel use cases, and open research challenges, which could be explored by researchers to make further advance in this field. The concept of secure chain of blocks is not a new idea. It was presented by South Harbor in 1991 as a means to digitally timestamp electronic documents to protect against tampering. However, it gained popularity in the recent years when used in blockchain technology to store transactions of the cryptocurrency called Bitcoin. There are two basic concepts of blockchain technology. First, peer-to-peer architecture. P2P is a distributed network architecture to share resources among participants, and it is a decentralized network whereby two individuals interact directly with each other without intermediation by a third party. Another basic concept of blockchain is cryptography. Cryptography refers to secure information and communication techniques derived from mathematical concepts and a set of rule-based calculations. It uses multiple methods such as encryption and decryption, hash chain, Merkle tree, digital signatures, and timestamps. Here are the characteristics of blockchain. Decentralization is the most important character in blockchain, refers to the transfer of authority and decision-making from a centralized entity to a distributed network. With transparency, blockchain is entirely traceable and much easier to maintain. All transactions are usually based on trust, which guarantees that the parties involved can depend on each other in fulfilling their commitments. Blockchain systems are inherently secure, as these systems use asymmetrical cryptography consisting of a set of public keys visible to anyone and a set of private keys visible to the owner. Once data is added to a blockchain, it cannot be altered or tampered with. Data traceability is to track the source, destination, and sequence of various updates, and the data goes through in between nodes. Anonymity characteristic of blockchain supports privacy, which is defined to be protected from unauthorized intrusion or observation. In a blockchain system, decisions are made democratically by all nodes using P2P approach. Data integrity is the assurance that the data in blockchain remains accurate and consistent over its entire life cycle. Blockchain technology is open source and users can develop applications. Blockchains are designed to be Byzantine fault tolerant, which means the network will come to a consensus even if some nodes are down or not acting correctly. Smart contracts on the blockchain can automatically perform transaction generation, decision-making, and the data storage using a specific consensus protocol. These days, blockchain systems suffer from challenges and issues such as scalability, performance issues, cost of decentralization, irreversible bugs, energy efficient, attacks on blockchain integrity, immutability hindrance, transaction processing, double spending problems. Also, blockchain has various security issues, including 51% vulnerability, private key security, criminal activity, money laundering, underground marketplace, double spending, transaction privacy leakage, computation and mining nodes, time consumption, confidentiality, integrity and authentication, communication overhead, and cryptographic primitives. To figure out these issues, blockchain use some algorithm to protect the blockchain security, such as hash function, digital signature, ZK snark, zero knowledge proofs, Monero ring signature. Thank you for listening.